Let's do a couple quick examples of using the rotation formulas. These formulas, two of the four really big formulas that we derived in class. Similar to what I'm going to ask you on this homework. So follow along, and the homework should be a lot more straightforward. So the first thing I'm going to do, first thing I ask you is to look at some simple cases when you rotate by a really nice, pretty angle like 2 pi or pi over 2, and see if the results make sense. And we're going to compare to the sketch pad in particular. Okay, so I'm going to do, let's do where theta equals 3 pi over 2. So here's the amount of rotation we're going to do, 3 pi over 2. And, okay, that's better. Okay, and I'm just going to plug that into here and see if the rotation formulas simplify in a way that makes sense, and then check it on the sketch. Okay, so I'm just going to copy those down and plug in 3 pi over 2, and because sine and cosine of 3 pi over 2 are nice and simple, just kidding, there we go, then we're going to get some nice simplifications. Now I'm going to leave x and y as variables because we're actually going to get a nice master formula. And we can look at it in a specific case, but I want to get the master formula for rotation by a special angle, namely 3 pi over 2. Okay, what are we going to get here? So, good place to pause and practice your circle values. Cosine 3 pi over 2, yes, that's 0. And so you get minus y times sine 3 pi over 2. Wait, that's minus 1, so you just get y. Nothing more, nothing less. Now, the sine and cosine switch places for the y. Now we're going to get a minus x, because sine 3 pi over 2 is minus 1 still, and cosine is 0. So all that happens is that x switches with y, and there's a minus sign. Okay, so that's the claim. That's how you that's what happens when you rotate by 3 pi over 2 counterclockwise. Equivalently, that's pi over 2 clockwise. Let's see. Let's look at the picture. Okay, so I have set up a point, just for convenience, something with fairly simple coordinates, 0.8, 0.6, 4/5 and 3/5. It's a nice little Pythagorean triple kind of thing. And then I went ahead and moved the blue dot that's measuring our rotation from 0 to pi over 2 to pi all the way to 3 pi over 2. And notice the point gets rotated by 270 degrees. The whole triangle gets rotated, but now we can kind of ignore that because that was for our derivation. And guess what? Let's look at what happens. Okay, it ends up in the fourth quadrant. So x is positive, but y is now negative. And guess what? The x's and y's have now switched, and then we got a minus sign. So indeed, the new x is just the old y. The new y is minus the old x. So it makes sense. And if we move the point, notice the closer I get to the x-axis in the original point, the closer I get to the y-axis in the rotated point, and vice versa, which makes sense in terms of the switching x and y. But then the signs make sense because this first quadrant gets rotated to the fourth, the second, where x is negative, gets rotated to the first quadrant where x is positive. It all works out. Okay, so let me take it back to 0.8, 0.6. Okay, and now what's the next one I want to do? I just want to do one more real quick. Okay, let's suppose I take that point. So here's a question that you're going to be doing. Rotate a random point. Doesn't actually have to be on the unit circle. The rotation formulas apply totally to any point in the plane. And I'm going to ask you to rotate 7,2 by 22 degrees. So let's change that. I'm going to use that same point to have the sketch of it. It happens to be on the unit circle, but that's not really that important for the rotation formulas. And let me rotate it by 115, for example. Not super hard. It's really about plugging into these master formulas again. Okay. So now I'm just going to plug in the 0.8 and the 0.6 and the 0.6 and the 0.8. And I'm going to plug in the 115 degrees. And I'm just going to copy and paste that. Just going to put that in for theta everywhere. Really rather straightforward. Okay, and then I'm just going to ask it to actually calculate it. So let's see what it gives me. It likes to do exact calculations, so I have to make it do a numerical. Minus 0.88 for the x prime and 0.47. It doesn't like to put them in the place where I want them to go. But there we go. So let's see if that agrees with what Sketchpad would tell us. Minus 0.88 and 0.47. Okay, so there's my point, and I'm going to crank the angle of rotation around to 115. Pretty close. And indeed, x prime is minus 0.88, and y prime is positive 0.47. So these formulas really work that we derived. Excellent.